All right, here are solutions for perfect problem 6 from Math 211. The idea here is to kind of combine a few different topics from our class. The idea of order of operations, the idea of operations in different bases, and then I guess different bases. Um, so you're given this expression here. You have this number in hexadecimal, aka base 16, minus this number divided by this number times this number plus this number. And first you're supposed to figure out what the value of this expression is. So evaluate this expression. And really the idea here, the challenge is to know what order to go in. So you don't do 4, 2 minus 2, 4, for example. You follow your order of operations where you first look for parentheses, then you look for exponents, and then contrary to popular belief, you don't look for multiplication next, you look for both multiplication and division. Those guys are tied, as are addition and subtraction. Ties, what the hell do I do with ties? Well, you can break ties by reading things left to right. Specific problem, you stare, you don't see any parentheses or exponents. So we move down here to our third level, multiplication and division. And you see multiplication here and division here. But remember, those tie. So you break ties by going left to right. In other words, you're going to do 2, 4 divided by 2 before you do 2 times 3. So 2, 4 divided by 2, well, 2, 4, this really represents two groups of 16 and 4 singles. So if you're dividing that amount of something between two people, what you could do is give each of them one of the two groups of 16 and give each of them two singles. In other words, what I'm saying is this thing is equal to 4, 2 minus 1, 2 times 3 plus c. And these are all in hexadecimal. I'm just a little bit lazy, so I'm not going to rewrite it on each one. So 2, 4 divided by 2 is just 1, 2, which I wrote here. And then you stare at this thing and you repeat. Well, again, no parentheses or exponents, but I do have multiplication here. So I can do 1, 2 times 3. And nothing carries, so this is relatively easy. This is one group of 16 and 2 singles. You multiply that by 3, you would have 3 groups of 16 and 6 singles. So I'll take you here. So far, we haven't really done anything out of the ordinary. We haven't really done anything that was dependent upon us being in base 16. But now we're going to, because now we've gotten rid of all the multiplication and division, but we still have addition and subtraction here and here. They tie, so we go left to right. In other words, we do this one first. 42 minus 3, 6. You're like, oh, that's just 6. No, it's not 42 minus 36. It's 4, 2. So 4 groups of 16 and 2 singles minus 3 groups of 16 and 6 singles. So you try to subtract 6 from 2, but you can't do that, so you have to carry, or borrow, I guess. So instead of thinking about this as 4 groups of 16 and 2 singles, I'll think about it as 3 groups of 16 and 18 singles. 18 minus 6 I can do. 18 minus 6 is 12. The way I write 12 is with the letter C when I'm in hexadecimal. So 4, 2 minus 3, 6 ends up being equal to C. And C plus C, well, that's 12 plus 12. 12 plus 12 gives me 24. But the way I write 24 in base 16 is I say that's one group of 16 and 8 singles. So the answer, what is this thing equal to? 1, 8. Not 18, but 1, 8, because we're in hexadecimal. That's the answer. And now what you're supposed to do in part B is add some parentheses to change the value of this thing. What if I wanted this thing to be equal to 0? Well, note that if I was subtracting here, if it were C minus C, then it'd be equal to 0. So how are you going to do that? How are you going to kind of change some signs on some things? Well, I think the way you can end up making this work is if you do 4, 2 minus this entire thing. So 2, 4 divided by 2 times 3 plus C. I think you'll end up with 0. And I don't know, you can get there kind of based on these results, or you could sort of guess and check your way there. And I can do this relatively quickly because I've done most of these calculations already. 2, 4 divided by 2 we already saw was equal to 1, 2. And 1, 2 times 3 we already saw was 3, 6. And just like 4, 2 minus 3, 6 was equal to C, 3, 6 plus C is going to be equal to 4, 2. So this is 4, 2 minus 4, 2, which is equal to 0. What I just did is I added one set of parentheses and got this thing to be equal to 0. To finish up this problem, now I want to add 3 sets of parentheses to change the value of this thing to 1. Well, again, you can guess and check, or you can kind of eliminate possibilities. How can I make this thing equal to 1? Turns out the only way to make it equal to 1 is if the last thing you do is this division here. How I'm going to make that division the last thing I do? Well, I could figure that out and then divide that by this. 2 problems. 1, this isn't equal to 1. 2, this is only 2 sets of parentheses. But that's okay. I'll show you why. If you do 4, 2 minus 2, 4 first, I don't think we've done that subtraction yet. So instead of thinking about this as 4 groups of 16 and 2 singles, I'll think about it as 3 groups of 16 and 18 singles. From those 18 singles, I want to take away 4 singles. That leaves me with 14 singles, which I write with the letter D. No, E. Yeah, I think that's right, E. Now I have 3 groups of 16 because I borrowed, minus 2 groups of 16. That leaves me with 1E over here. 1E, in other words, 16 and 14 more. In other words, 30. I have 30 on this side. If I get 30 on this side, 30 divided by 30 would be equal to 1. Problem. This thing right here is not 30. It's not 30 because 6 plus C is not going to get me up to 30. Let's see. C is equal to 12. 6 plus 12, that's not high enough. But what I can do if I want to make this bigger is I can do the multiplication later in the process. Right? Loosely speaking, multiplication makes things bigger quicker than addition does. So if I increase one of the numbers, one of the factors in my multiplication by putting the parentheses here, I can make this thing bigger. Will it be the perfect amount? Well, let's see. If I do 3 plus C, C is equal to 12. 12 plus 3 more is equal to 15. 15 I write with an F. And if I do 2 times F, well, F is 15. So 2 times 15 is 30. And as we saw over here, the way you write 30 is 1E. And 1E divided by 1E, anytime you divide a number by itself, you get the number 1. So what I did is I added 3 sets of parentheses here to get my answer equal to 1. Guess I should write a little hex here. And that's the solution to this problem. So I guess I'll end the video here.